Okay, so let's continue. Okay. So we introduce this notation for distribution. So the distribution is just such a table. X can be those those numbers, and then probability for each case is this. So such a table is distribution. So we have many distributions, right? So let's focus on some typical distribution. So the simplest distribution is 1-0 distribution. So we call those 1-0 distribution as a Bernoulli distribution. Okay, so x can be 1, x can be 0, and the probability for x equal 1 is p, and probability for x equals 0 is q. So here p plus q should be 1. So we can, okay, so this 1-0 distribution is the simplest distribution. So for each distribution, we want to find the two important numbers, mean and variance. So mean, so let's check what is the mean and what is the variance of those 1-0 distribution. So we have this result: mean is equal p, and variance sigma square equal pq. So how can we? So let's confirm this. Like, how can we get that? So let's check what is mu. So mu is expectation x. So what is x here? So x equal, x can be 1, so 1 times p, plus x can be 0, 0 times q. So this equal p, right? Okay, so what is the variance? Variance sigma square equal Vx, variance of x. So what is the variance? The definition is equal E x minus mu squared, x minus mu square's average. So let's say, I put this, let's say that. So x can be 1. So x minus mu is p, can be 1 minus p squared. Or x can be 0, so 0 minus p squared, right? So x minus mu can be 1 minus p squared or 0 minus p squared. So the E means we need to multiply the probability. So here, this thing happens p plus this happen probability q. So this equal 1 minus p squared multiply p plus 0 minus p squared multiplied by q, right? Then so we simplify a little bit. So 1 minus p, actually q, so this is q square p, right? Plus, so 0 minus p squared is a p square q. And here we can take a pq outside, pq, so q plus p. So q plus p equal 1, so this equal pq, right? So for this 1-0 distribution or Bernoulli distribution, so we can easily get this. Mean is mu, mean is p, mu is p, and variance is pq. So this 1-0 distribution, we can understand that x equal 1 is just something happening. Happening is 1, not happening is 0. Okay? Okay, so we can regard this is just if we try something, this thing happening or not happening. Happening is 1, not happening is 0. Okay? So we have many of those kind of problems. Like from 52 cards, pick one card. If we can get ace, and so we can regard x equal 1 is you get 1 ace. Like x equal 1 means this thing happening. So x equal 0 means this is not happening, right? Okay. So here we can regard this as try one time. Try one time, so something happening or not happening. Okay. So now let's consider let's check the general situation. If try in time, try one time, try in time, how many good things happen? Like here we can regard 1-0 is this x equal 1, good thing happen one time, or good thing happen 0 time, right? Try one. So try how about so in general try many times. So number of success, so this one we don't know, so this is landing variable. Okay, so now let's check some example. So suppose in our first quiz we have only one question. So this multiple choice question, like we have 5 choices, A, B, C, D, E. Okay? So you pick your answer randomly. So this means that you don't know the answer. You just pick A, B, C, D, E randomly. So what is the chance we have those kind of, what is the chance you can get a correct answer? Or what is the chance you cannot get a wrong answer? Okay. So we let x be the number of your correct answers. So this x can be you get a 1 correct or 0 correct. Okay, and the probability. Okay, so what is the probability you can get the correct answer? That's 1/5, right? And then not correct 4/5. So here 1 and 0 means you pick a correct answer or you pick the wrong answer. Okay. Okay, so this is easy. So now let's check so let's increase the number of questions. Like how about 2 questions? So each one has 5 choices, A, B, C, D, E, A, B, C, D, E. Okay, so we let x be the same thing. X be the number of your correct answer. So in this case, x can be, let's say, x. So best case, you get 2. You answer correct. 2 answer correct for all those 2 questions. All can be 1, and all can be 0, right? So let's check the probability. So what is the probability you get 2 correct answers? So this means first one is correct, second one also correct. So first one corrected 1/5, second one 1/5, right? So what is the probability for x equals 0? For x equals 0 is 4/5. First one not correct, Second one also not correct, right? So we can find the probability for x equal 1, 1 correct. So we can use this way, like, because the total probability is 1. So here, 1 over 25 or 6. So here we can simplify this. The first one, 1 over 25. This is the chance you answer both of them correctly, and both of them not correctly. Then here, what is this number should be? I think make this just also 25. So should be 8, right? Yeah. So 8 over 25 is a probability you get 1 correct. Okay, so this probability also can check directly. We say that x equal 1, meaning you get 1 correct. So could it be like this? The first one, let's say, first one is correct, second one is wrong, plus this. First one answer wrongly, second one correctly, right? So there's a probability this one, first one correct, 1 over 5, 4 over 5, right? Plus the first one not correct, 4 over 5, second one correct, 1 over 5. So this equal 8 over 25, right? Okay. So we have so we can have this distribution. We can use this, right? Okay. So x 1 over 5, 1 over 5. We put it together, like x equal can be 2, can be 0, log can be 1, can be 0. So the probability is 1 over 25, 8 over 25, and 16 over 25. Okay, so we say for a quiz, only 2 questions, usually too few. So usually should be like 10 questions or 20 questions. So let's say so by now we have 10 questions. So each one is A, B, C, D, E, 5 choices, A, B, C, D, E. Then we just talking about the same things. Right? Let x be the number of your correct answers. Find the distribution for x. So in here, the table is too big, right? Like can be x, can be 10, can be 9. Like you, x equal 10 is the best case. You answer them all correctly. So x can be 10, can be 9, can be 8, and can be 3, can be 2, can be 1, and can be 0. And so then we need to find out probabilities. So for each one, find out each probabilities. Okay, so we say, oh, this is too much work. This table is too long, so we don't like use this big table to denote the distribution. Okay, so we focus on, let's consider general situation. Like we say, try n times. Like here we say, like, you answer question correctly, like you answer question randomly. This means that you just first one you have no idea, just try. Second one, no idea, just try. Right? You just pick answer randomly. Okay. So we can consider general scenario, general situation. We just try n times. So well, for each try, we have 2 outcomes. You can success or you can be fail, not success. So probabilities are just p cubed. success P, not success Q. So we let this X be the number of successes. So we want to find the distribution. So we say there's a distribution. If we use a table, there's just too long. X can be n, right? N minus 1 and 3 or 2, 1, 0, right? Okay. So we say this, if n is big, then the table is big. So we don't like. So here, we just focus on the probabilities for each one. X equal n or x equal k. So we just focus on this probability. Okay. So we have this formula. So probability x equal k equals thus. So once we have all those probabilities, then we have the distribution. So here we can use this formula, the probability formula, to denote this distribution. And by the way, such a distribution we call a binomial distribution. Okay. So binomial distribution is try something many times, n times, and for each one we have two cases, good case, bad case. So here bi means 2, right? Okay, binomial distribution. Okay, so let's check why we have this formula. Okay, so here we can say like we just have n trials. We have key success. So this key success could be here, could be, or could be like this, right? So success is P. So this success probably P. So P happened k time. P. And all others is Q. So how many Q is n minus kq, right? All others are Q. So we have many those situations. Could be like this k success, could be this k or this k. So this how many of such a case? So this equal like from n positions, we just pick a k position. For those k position, we just put those as correct. Right, this thing happen. So how many such way? So we just say we have so many ways from n. Just pick a k position. For those k position, success, and other n minus k position, fail. Okay, so we have this formula, right? X equal k. X equal k is good thing happen k time. Okay. So we regard this formula as binomial distribution. So once we have the formula, then if the if the number of n is big, it doesn't matter, right? So here we can consider this problem. In our first quiz, there are 10 questions. Yeah, not easy, but anyway, like there are 10 questions. So each one, just 5 choice, A, B, C, D, E. So you pick your answer randomly. What is probably can get exactly like 6 questions correctly. So this means like good things, we just need to find this probably. Good thing happen 6 times. X equals 6. So for such a problem, we just use this formula. From 10 questions, you just pick 6 questions. So for them, you answer correctly. So correctly, the probability is 1/5, right? So this thing happens 6 times. Good thing happens 6 times. And then bad thing happen remaining 4 times. So bad thing not correct is thus, like this thing happen 4 times. Okay. So this is our answer. We don't. We just put this as our final answer. We don't need to find a numerical value, right? We just keep this. Okay. So if we use this, is such a problem easy. Okay, so easy. Okay. So there's a problem also easy, like exact 2 questions correctly. So total how many? This is 3 questions. And but here I changing a little bit here. But each questions has 4 choices, A, B, C, D, 4. So we just use the formula. Okay, so Px equal 2. We get the 2 question correctly is among 3 questions. I just choose 2 questions. For them, I answer correctly. Answer correctly by now become 1/4, right? So answer correctly happen twice, and not correctly happen 1. Okay. So good thing happen 2 times, and bad thing happen 1 time. Okay. So for 3 questions, I answer 2 questions correctly, 1 question not correctly. Okay. Okay. So using the formula, we using the formula, such a problem easy. Okay. So we say binomial distribution. If the answer is if for each one is just 2 cases, good or bad, or some people like if we would like some people say like this guy or not like this guy, only like 2 options, 2 outcomes, saying there's a binomial distribution. So let's check this problem. Like let's say for my teaching, some people suppose you like me or do not like me. Just only 2 cases, right? So now suppose like in our class we have 25 students. Okay, so we want to find so how many. So we want to find the probability that exactly 20 people like my teaching. Okay, 20 like, saying this means 5 not like, right? So such a probability is just we just choose 20, right? From 25 choose 20, so 20 like. So what is probability for like? So this is like suppose my teaching popularity is 70. 70% of people will like my teaching. So this we can regard as a probability, right? Probability for like is 70% or 0.7. So this thing happen 20 times for 20 students. Okay, so this thing 20 students say yes, they like, and then the 5 people will not like it, not like 0.3, right? So not like happen 5 times, right? So we just use this formula, easy, right? So okay. Okay, so we say use the formula. It seems easy. Like let's say so in our first quiz, suppose we have 20 questions. So each with 4 choices. So A, B, C, D. So you pick answer randomly. So we want to find suppose like let's say passing, if you get at least like a 60%, I will let you pass the exam. So 60 over 20 should be 12, right? So we want to find out what is the probability you can get at least 12 questions correctly, at least. So not exact. So this problem is just like that, like x at least equal 12. So this at least is equal to is larger than or equal, could be x equal 12, or could be 13, could be could be 20, right? So here we have too many cases, not one case, too many cases. And so even though we have the formula for x equal 12, x equal 13, like let's say x equal 12 plus, so this is exactly like, so x equal 12, x equal 13, plus x equal 20. So for each one we have a formula. Let's say what is x equal 12. So we say from 20 questions, pick 12 questions. So for those 12 questions, answer them correctly. Pick correct answer is 1 over 4, 1 over 4, 1 over 4 happen 20 times. And then not sorry, 12 times, right? And this other one 4 over no 3 over 4, 3 over 4, 3 over 4 happen 8 times. Yeah, that's 20. So plus 30, x equals 13 is like 20. Choose 13 questions. So this thing happen, good thing happen 13 times, and the bad thing happen 7 times, and then plus. So we have many terms, add them together. So in mathematical point of view, we can use this notation. We use sigma, summation. Sigma, so in general we say this thing is equal 20, choose k. 20 questions, choose k questions. And this answer those k questions correctly. So this good thing happen k time. And then bad thing happen 20 minus k time. I totally 20 questions. And then there's k, just start from 12 to 20. Okay. So from mathematical point of view, we answer this question. So what is the probability that you can get at least 12 questions correctly? We say the answer is this. This formula, summation from k for k start from 12 to 20, like this. Okay, so there's a probability just like the probability you we can regard this is probability you pass the exam. Pass the exam without any study, just based on your lucky, right? So how much chance you can pass the exam without any study? So we say we have the mathematical formula, but for such a question, we are interested in those questions. We have some interest. We want to know the numerical value, not like there's a formula. We just try find what is how much chance, 5% chance or 10% chance. So if this percentage chance is too high, then like I will change the policy. Like I usually I should make this probability is very small. If there's probably 10%, this is too high, right? So it seems like some people can pass the exam without any study, right? If 10%, this means 10%, we have 2 people or 3 people in one class can pass the exam. So I should not let this thing happen. So we should make this probability very quite small, like only 1% or 0.1%, like that, right? So anyway, like here, we prefer not. So we prefer to find this probability, the numerical answer equal how much, like equal numerical like 0 point something something like that. We prefer numerical answer. So the question is, how can we do that? So we say we can use calculate, but calculate here calculate is first questions we have too many terms, right? 12, 13, 14. We have too many terms, too many calculations. So the other question is maybe those number, even though we use calculate, actually we cannot use calculator to do those calculations. So why? Because those number is too big and those numbers are too small. So for example, let's say like x equal 12. Let's say what is this number? 20 choose 12. This number is too big. What is this number? This number equal, we say multiply 12 numbers, right? From 20. Oh, this is just too big. This is also tedious. We should multiply 12 numbers. So here 1 time 2 time 12, like that, right? So this number usually too big. And then what is this number? 1 over 4 12. So this equal 1 over 4, 1 over 4, 1, just 1. So here 4 12's power. 4 12's power. This number is too big. And 1 over 4 12 is too small. So you calculate, maybe can only you can only keep like 8 digit or 16 digit. But this is the out of this range. So we say we cannot use calculate do those calculations. Maybe if we use a very powerful computer, maybe you can do that. But anyway, we wanted to solve this problem. In this class we do not use computer. So how can we get a numerical answer for those questions? So okay, so we leave this issue for our next class. Okay, so next class we try to solve such a problem. Okay. Okay, so this is today's class. Okay, so today's class, the topic is distribution. So what is the distribution? Distributions put all probabilities together, or put all cases together. Oh, so we can use this a table, and we can use a formula to denote a distribution, right? To represent the distribution. And also we check some typical distribution. So typical distribution is just 1-0 distribution, or try one time. Try one time, and outcomes two outcomes. You can success or fail. This thing can happen or not happen, right? So typical example is just like multiple choice question, just over homework, or over we have like a homework. I just give you four choices, right? You just pick your answer correct. You just pick your answers. So if okay, so if we have many questions, then this become like a binomial distribution. So binomial distribution is a typical distribution. Okay, so from what binomial distribution, we say if we find the probability for exactly how many, then just one term. So one term we can use the formula. We just regard the formula as our final answer. But we also can have those kind of questions, at least how many. So this at least is involve many terms. And also like the answer we prefer have a numerical answer. So we have some trouble for this, right? So we will discuss, we will try to solve such a problem next class. Okay, so again, this class topic is distribution. So last class topic is probability. So distribution is put many probabilities together. That's distribution. Okay, and so we also will discuss some typical distribution. So one of the typical distribution is just a binomial distribution. Okay, okay. So we can stop here. Also, thank you. So see you next class. I hope next class weather will be good. Okay.